We've been pointing our telescopes at the wrong places. For decades, the search for alien life has been obsessed with planets. But the moons, the things orbiting those planets, might be where life has been hiding all along. And some of them are stranger, more alive, and more terrifying than anything science fiction ever imagined. These are the 8 moons in our solar system that could have alien life right now. Enceladus, a moon that broke every rule scientists had about where life could exist. Enceladus is smaller than the UK, but it's been silently shooting water into space for billions of years, not just water vapor. Entire jets of ocean spray bursting through cracks in its south pole and firing hundreds of kilometers into space. NASA flew a probe straight through those jets and tasted them. What they found inside wasn't just water. It was organic molecules, the building blocks of proteins, amino acid precursors. All of it formed not on the surface, but deep inside Enceladus's hidden ocean. An ocean warmed by a rocky seafloor reacting with liquid water, exactly the kind of environment where life first appeared on Earth. ESA is now planning a dedicated mission to land directly on the South Pole and sample those jets. Scientists say even finding no life, there would be one of the most important discoveries in human history. Because the ingredients are so perfect, the absence itself would need explaining. Europa. It has an ocean twice the size of every ocean on Earth combined, and it's been locked under a shell of ice for billions of years. For a long time, the question was, how do nutrients ever reach it? Sunlight can't get through. Nothing can reach the ocean from above, but Jupiter can. Jupiter's radiation bombards Europa's surface constantly, converting the ice into oxygen and hydrogen peroxide. Then something remarkable happens. Recent models show that chunks of this nutrient-rich, radiation-processed surface ice crack off and physically sink through the ice shell and drop into the ocean below, a process scientists are calling crustal delamination. The ocean is feeding itself from above. It's taking the chemicals forged in Jupiter's radiation and pulling them down to where they're needed. NASA's Europa Clipper, launched in 2024, is on its way there now to measure the ice thickness and test exactly this. If the chemistry checks out, Europa becomes the leading candidate for life in the solar system. Titan. This is the only moon in the solar system with a real atmosphere. It's thicker than Earth's. It has rain, rivers, lakes, and seasons, but none of it is water. Every lake on Titan is liquid methane. It rains oily hydrocarbons. The rivers run black and slow, pooling into seas of fuel. For years, scientists assumed nothing could live in that. It's far too cold, too alien, too different from the chemistry life needs. Then researchers found something unexpected. Certain molecules in Titan's oily seas can spontaneously self-assemble into tiny hollow spheres. The same structural trick that cell membranes use on Earth, except built entirely from hydrocarbons, with no water involved at all. Life on Titan, if it exists, would be so chemically alien that we might not recognize it. And to make it weirder, underneath Titan's crust, there may be a second ocean, a deep, hidden water ocean. Meaning Titan could host 2 completely different forms of life simultaneously, one on the surface and one buried miles below it. Mimas. This one shattered what we thought we knew. Mimas is Saturn's Death Star moon, heavily cratered, ancient-looking, geologically dead. No geysers, no heat signatures, no signs of anything happening beneath the surface. Scientists ignored it for decades. Then in 2024, researchers went back through Cassini's orbital data and found something that should not be there. Mimas' wobble, the way it rocks as it orbits Saturn, could only be explained one way. There is a liquid ocean hidden beneath that battered, frozen shell. And here's the part that genuinely stunned the scientific community. That ocean may have only formed somewhere between 2 and 25 million years ago. In geological time, that's almost nothing. Which means somewhere in our solar system, a world that looked completely dead just woke up. Its interior is still warming. Its ocean is still young. And the immediate question scientists are now asking is, if Mimas can quietly develop an ocean with 0 warning signs, how many other moons out there are doing the same thing right now? And we just haven't looked closely enough? Ganymede. It is the largest moon in the entire solar system, bigger than the planet Mercury, and it holds more liquid water than every ocean on Earth combined. But what makes it genuinely strange is something no other moon in the solar system has, its own magnetic field. Ganymede generates its own magnetic force field, like a miniature planet. And the Hubble Space Telescope recently detected something escaping from its warm equatorial regions, actual water vapor rising off the surface and into space. Ganymede is so water-rich that it's leaking. Underneath that thick, 100-kilometer ice shell sits an ocean that may have been liquid for billions of years, heated both by radioactive decay in its core and by the enormous magnetic influence of Jupiter squeezing and flexing the moon's interior. ESA's JUICE spacecraft is already flying toward Jupiter right now, and it will orbit Ganymede directly. The first spacecraft ever to orbit a moon other than our own. What it finds could rewrite everything we think about how many oceans this solar system actually has. Triton. this moon should be dead. It orbits Neptune at the very edge of the solar system, more than 4 billion kilometers from the sun. It's so cold that nitrogen freezes solid on the ground. And yet, when Voyager 2 flew past it in 1989, the only spacecraft that ever has, it found something impossible: active geysers erupting from the surface, shooting dark plumes kilometers into the thin atmosphere. Something inside Triton is warm. Scientists believe the key is its orbit. Triton moves backward around Neptune, the wrong direction compared to everything else, which means it was captured, violently, from somewhere in deep space. That capture event stirred Triton's interior so violently that it generated enormous heat. And models now suggest that heat may still be sustaining a liquid ocean beneath its thick ice shell today. A proposed NASA mission called Trident was designed specifically to investigate Triton. If it's ever approved and launched, it would be the first spacecraft to visit the outermost ocean world in the solar system, a place that gets less sunlight in a year than Earth gets in a few minutes. Uranus's 4 moons. Until 2023, the moons of Uranus weren't even on the list. They were too small, too cold, too far from any meaningful energy source to hold liquid water. Then JPL scientists went back and reran the models with better data and found they had been wrong about all 4. Ariel, Umbriel, Titania, and Oberon, 4 of Uranus's moons, all appear to have hidden oceans beneath their ice shells, kept liquid by the slow release of heat from radioactive elements decaying in their rocky cores. Not 1 ocean, not 2, 4 of them, quietly sitting there. Titania and Oberon, the 2 largest, might have oceans warm enough for complex chemistry. And there are faint traces of ancient cryovolcanic flows on Ariel's surface, frozen scars from a time when liquid water erupted from below and froze in seconds. The kicker is that we haven't sent anything to Uranus in nearly 40 years. Voyager 2 flew past in 1986 and never returned. Everything we know about these 4 oceans comes from indirect evidence and mathematics. The planetary science community's top priority for the next decade is an orbiter around Uranus. If it launches, it would encounter a system with at least 4 hidden oceans that humanity has never directly explored. Rogue planet moons. The final one doesn't orbit a star at all. When a giant planet gets ejected from its solar system, thrown out by gravitational chaos into the dark between the stars, it sometimes takes its moons with it. Those moons drift in permanent darkness, billions of kilometers from the nearest sun, in temperatures close to absolute zero. They should be dead, frozen, sterile. But a 2026 study found something that changes everything. If a moon has a thick enough hydrogen atmosphere, that atmosphere acts as a blanket, trapping the heat generated by tidal flexing between the moon and its wandering planet. Models show this can keep a subsurface ocean liquid for up to 4.3 billion years, long enough for life not just to start, but to evolve into something complex. And these rogue planets are not rare. Current estimates suggest they may outnumber stars in the Milky Way. If even a fraction of them carry moons with hydrogen atmospheres, there could be millions of living worlds drifting in complete darkness right now. Invisible, unreachable, warmed only by gravity, cut off from the universe forever. We've been searching for life in sunlight. It may have been hiding in the dark the whole time. 8 moons, 8 hidden oceans. And we've only scratched the surface of what's actually out there. Every single time we've looked at a world we thought was dead, we've found water. The universe isn't a sterile, empty place. It's a place full of hidden oceans, quietly waiting. If that idea keeps you up at night, subscribe, because we're going deeper every week. And if you want to know what we might actually find living in those oceans, that video is right here.